Hello everybody, here is the final exam review class video. In this video we will do the odd problems of the final exam review packet that I gave you in class. The solutions to the even problems can be found on the Google Classroom or the Google website. Remember that you have the ability to pause, rewind, or fast forward during this video. Number 1. Given f of x equals x squared plus 5 and g of x equals e to the x minus 7, find f of g of x. Remember that f of g of x is equal to f of g of x. We should always start with the inner function. So we should substitute e to the x minus 7 for g of x. So now into f we should plug in e to the x minus 7. That means instead of that x we need to substitute e to the x minus 7. From this we will obtain the quantity e to the x minus 7 squared plus 5. Now we should simplify. So write out e to the x minus 7 twice so that we can distribute. After multiplying, we will obtain the quantity e to the x squared minus 14 e to the x plus 49 plus 5. We can simplify a little bit more. Remember that we can distribute exponents here. Therefore, we will get e to the 2x minus 14 e to the x plus 54. Here's our final answer. Number 3. Use long division to divide f of x by x minus 2. Make a conclusion statement by expressing f in the form f of x equals d of x times q of x plus r of x. Is x minus 2 a factor, yes or no? First, we'll set up our long division. We should be focusing on leading terms. We see that x goes into 2x cubed, 2x squared times. Now it's time to multiply. We'll get 2x cubed minus 4x squared. At this point we subtract, which means change the signs. We see that we get a cancellation and we're left with negative x squared. It's time to drop the positive 3x. Time to continue the process. We're wondering how many times does x go into negative x squared? X goes into negative x squared negative x times. Multiply to get negative x squared plus 2x. Now it's time to subtract, so we can change the signs. Again, we'll get a cancellation and we are left with x. Drop the positive 1 and continue the process. X goes into x one time, so therefore we got plus 1. Multiply to get x minus 2 and then subtract, which means change the signs. The remainder is 3, so up here we can put R3. It's time to use our division to make a conclusion statement. We see that f of x is equal to x minus 2 times 2x squared minus x plus 1 plus 3. Remember that x minus 2 is called the divisor, 2x squared minus x plus 1 is called the quotient, and 3 is the remainder. Since the remainder is not equal to 0, x minus 2 is not a factor. We just used the factor theorem, which states that x minus k is a factor if and only if the remainder is 0. Number 5. Given f of x equals x squared plus 3 and g of x is 4x minus 1. Find each of the following and determine their domains. State the domains in interval notation. First we will find f times g, which equals x squared plus 3 times 4x minus 1. Distribute to obtain 4x cubed minus x squared plus 12x minus 3. The domain of f times g is the intersection of the domains of f and g. So since the domain of f is all real numbers and the domain of g is all real numbers, the domain of f times g is all real numbers. Therefore, our domain is the set of all x such that x is in the interval negative infinity to infinity. F divided by g is equal to x squared plus 3 divided by 4x minus 1. There is one main restriction that we should notice. The denominator cannot equal 0. That means that x cannot equal 1/4. We have to write our domain using an interval, so it might be helpful to graph our domain on the number line. X cannot equal 1/4, but x can be anything else. Using this graph, we can see that the domain is the set of all x such that x is in the interval negative infinity to 1/4, union 1/4 to infinity. 1/4 is not included in the domain. Number 7. Find two functions f and g such that h of x is equal to f of g of x. Verify your result. H of x equals e to the 5x plus 7. In this problem, we want to find an inner function and an outer function. A good candidate for the inner function is 5x plus 7. That means that the outer function would be e to the x. Remember our tip. To find the outer function, replace whatever we circle for our inner function with an x. Now we will verify our answer. Is h of x equal to the composition of the two functions we just chose? To check, perform the composition and remember to start with the inner function. Is h of x equal to f of 5x plus 7? Into f, plug in a 5x plus 7. Is h of x equal to e to the 5x plus 7? Yes, checked. Therefore, h of x is the composition of the two functions we just chose. Number 9. Find the exact value using a sum or difference formula, the sine of 13 pi divided by 12. Our strategy is to write 13 pi divided by 12 in terms of two angles that we know on our unit circle. Our math tip was to pick two angles that we know will reduce. For example, 9 pi over 12 plus 14 pi over 12 will work, and both of those angles reduce to 3 pi over 4 plus pi over 3. There are many pairs of angles that will work, so here are a couple of other possibilities. Pause the video right now and make sure you understand these. To build our solution, we'll use the first one. The sine of 13 pi twelfths is equal to the sine of 3 pi over 4 plus pi over 3. We need to use the sum formula for sine. A is equal to 3 pi over 4, B is equal to pi over 3. Now we will make our substitutions. Now we will use our unit circles to evaluate. The sine of 3 pi over 4 is root 2 over 2. Cosine of pi over 3 is root 3 over 2. The cosine of 3 pi over 4 is negative root 2 over 2. And the sine of pi over 3 is 1/2. Multiply to obtain root 6 divided by 4 minus root 2 divided by 4. Don't forget to multiply 2 times 2 to get 4. Since we have a common denominator, we have our final answer. Root 6 minus root 2, all divided by 4. Number 11. Determine whether the given function is even, odd, or neither. Only an algebraic solution will be accepted. F of x equals 2x to the fourth plus 5x squared plus 3. To make a conclusion, we have to evaluate f of negative x. By plugging in a negative x, we will obtain 2 times the quantity negative x to the fourth plus 5 times the quantity negative x squared plus 3. Simplify to obtain f of negative x equals 2x to the fourth plus 5x squared plus 3. Therefore, since f of negative x equals f of x, f is an even function. Here are a couple of reminders. F is even if and only if f of negative x equals f of x. Number 2, f is odd if and only if f of negative x equals the negative of f of x. Number 3, f is neither if and only if f of negative x is not equal to f of x and f of negative x is not equal to the negative of f of x. Here are some tips for simplifying. Number 1, the quantity negative x to the fourth is equal to negative x times negative x times negative x times negative x. By multiplying, we see that we get positive x to the fourth. This type of thing will happen when our exponent is even. Tip number 2, suppose that our exponent is odd. For example, suppose we have the quantity negative x cubed. That's equal to negative x times negative x times negative x. Negative times negative times negative is negative, and we'll get x cubed. So this sort of thing happens when the exponent is odd. We should notice that the quantity negative x to the fourth is not equal to negative x to the fourth. That's why it's very important to use parentheses right here in this substitution step. Number 13, find the exact value of the expression the sine of 5 pi over 3 times cosine of 5 pi over 6 minus the tangent of 3 pi over 4. We can use our unit circles to evaluate. The sine of 5 pi over 3 is negative root 3 over 2. The cosine of 5 pi over 6 is negative root 3 over 2. The tangent of 3 pi over 4 is negative 1. Simplify to obtain 3/4 plus 1. 3/4 plus 1 is 7/4. Number 15, find the domain. Express your answer in interval notation. G of x is equal to the square root of 12 minus 4x. There is one major restriction that we should notice. 12 minus 4x, the number underneath the radical, cannot be negative. Boom, boom. That means that it can be positive or it can be 0. Using this information, we see that 12 minus 4x is greater than or equal to 0. Solve the inequality to obtain x is less than or equal to 3. Make sure that we flip the symbol since we're dividing by negative 4. So far we have an inequality, but the directions say to express our answer using an interval. It's helpful to graph our solution on the number line. That way we can see that our domain is the set of all x such that x is in the interval 3 to infinity, where we are including the 3. Number 17, find the x-intercepts, vertical asymptotes, and vertical asymptotes for j of x. Is there a hole in the graph? To analyze a rational function, we should simplify first if possible. That means that we should factor the numerator and denominator and see if there are any cancellations. Now we should do some side work for our numerator. we see that the only way we're going to get 2x squared is 2x times x. Now we need factors of 15 so that when we FOIL, we'll get positive 7. Those factors are 5 and 3. If we FOIL, we'll get a 3x and a 10x. We can obtain a positive 7 with a positive 10 and a negative 3. So therefore, minus with the 3, plus with the 5. By factoring, we can obtain 2x minus 3 times x plus 5, all divided by x minus 4 times x plus 5. There's a cancellation. Therefore, we're left with 2x minus 3 divided by x minus 4. Don't forget your domain restriction. We see that x cannot equal negative 5. The domain restriction tells us that there is a hole in the graph when x equals negative 5. To get the location of the hole, plug a negative 5 into the simplified version. We'll get the point negative 5, 13/9. For the rest of our analysis, we should look at the simplified version. To find the x-intercept, set the numerator equal to 0. We'll get the point 3/2, 0. Remember that the x-intercept is a point, so our final answer should be a point. To find the vertical asymptote, set the denominator equal to 0, and we'll get the equation x equals 4. To find the horizontal asymptote, compare the degrees of the numerator and the denominator. The degree of the numerator is 1, the degree of the denominator is 1. That means that y equals the ratio of the leading coefficients. That ratio is 2 over 1. So that means that the horizontal asymptote is y equals 2. To find the horizontal asymptote of a rational function, we observed 3 cases. Case 1. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. Case 2. If the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is y equals the ratio of the leading coefficients. For a quick example, consider f of x. The degree of the numerator is 3. The degree of the denominator is 3. That means that the horizontal asymptote is y equals the ratio of the coefficients. That ratio is 2/5. Y equals 2/5. Case 3. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Number 19. Use the properties of logarithms to expand the expression as a sum, difference, and/or constant multiple of logarithms. For this problem, we should remember our rules for expanding or condensing logs. First, identify an anything and a bennything. We can see now that we need to use the quotient rule. We see that our given log equals the ln of x to the 5th y to the 10th minus the ln of z to the 15th. Now we can notice that we have a product. So here is another anything and bennything. We can use the product rule to break this apart. From this, we will get the ln of x to the 5th plus the ln of y to the 10th minus the ln of z to the 15th. Whee! Now we can use our slide rule. So we get our final answer. 5 times the ln of x plus 10 times the ln of y minus 15 times the ln of z. Number 21. Condense the expression to a logarithm of a single quantity. Step 1. Ew! We have to put the exponents back where they belong. Here we're using the reverse slide rule. So we will get the log base 2013 of x cubed minus log base 2013 of x minus 1 to the 8th plus the log base 2013 of y squared. when we are condensing logs, we should only consider 2 logs at a time. Right now, we're looking at 2 logs separated by a minus sign. We can use the quotient rule to condense those 2 logs into 1 log. We will get log base 2013 of the quotient x cubed divided by x minus 1 to the 8th. And we still have this other log hanging around over here. Now we should notice that we have 2 logs separated by a plus sign, so we can use the product rule. Using the product rule, we can condense those 2 logs into an expression with 1 log. We will obtain the log base 2013 of x cubed divided by x minus 1 to the 8th times y squared. Remember that y squared is the same as y squared divided by 1, so that means we get our final answer. Log base 2013 of x cubed times y squared, all divided by x minus 1 to the 8th. Number 23. Factor completely and find all real solutions for the equation x cubed minus 9x squared plus 27x minus 27 equals 0. First of all, we should notice that factoring by grouping is not going to help us out. If we were to try it, then we can take out an x squared from the first group. We're left with x minus 9. And we can take out a 27 from the second group. We're left with x minus 1, but we don't have a GCF to continue. So factoring by grouping is not helping. So instead, we should start looking for possible rational roots. Factors of negative 27 are plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. And also we're looking for factors of 1, so that would be plus or minus 1. Therefore, our possible rational roots are plus or minus 1, plus or minus 3, plus or minus 9, plus or minus 27. There are 8 possibilities. If we wanted to, we could use guess and check until we find a 0, but it will probably be easier if we use our calculator. Here's a screenshot of my calculator after I plugged in the function. We can see that x equals 3 is a 0. That means we should be able to divide by x minus 3. So now we'll do our synthetic division. Since we're dividing by x minus 3, we got to put a positive 3 outside the jobber. Take a couple seconds, perform the synthetic division, and make sure you get a remainder of 0. So now we can start answering the question. Here is the original equation. We're factoring out x minus 3, and we're left with x squared minus 6x plus 9. That all equals 0. This quadratic can be factored, and we're left with x equals 3. Notice that this root occurs with a multiplicity of 3. That's why it crosses the x-axis. Number 25. Find the exact value. The tangent of the arc cosine of negative 3/5. First, let's make sure we remember our ranges. If y equals arc sine of x, then the range is negative pi over 2 is less than or equal to y, and y is less than or equal to pi over 2. If y equals arc cosine of x, then the range is 0 is less than or equal to y, and y is less than or equal to pi. If y equals arc tangent of x, then the range is negative pi over 2 is less than y, and y is less than pi over 2. We should memorize these. Okay, back to the problem. We're evaluating a composition here, so we have to consider the inside first. So we started analyzing y equals the arc cosine of negative 3/5. Next, take the cosine of both sides. You'll get cosine of y equals negative 3/5. That's because cosine of the arc cosine cancels, so you're just left with negative 3/5. Alright, the range for arc cosine is 0 is less than or equal to y, which is less than or equal to pi. Next, we went over here, all students take calculus. In this problem, the angle is between 0 and pi. Also, the cosine of the angle is negative. So that means of these two quadrants, our angle is in the second quadrant. So we should draw a picture of an angle in the second quadrant. And then the cosine of the angle is adjacent over hypotenuse. That means that the missing side is 4. So with the completely labeled reference triangle, we can answer the question. The tangent of the arc cosine of -3/5 is equal to the tangent of y. Right here we made a substitution because in the beginning of the problem we called arc cosine y. So now we have to find the tangent of y. Well, to find the tangent of y, look at the triangle. We're after opposite over adjacent. So that would be 4 divided by -3, or -4/3. Number 27, determine two vertical asymptotes for the function y equals 10 tangent of 2x minus pi over 4. There's a summary table in our notes about our trig graphing material. So you should go back into your notes and you should make sure you memorize that stuff. The vertical asymptotes for a tangent function occur where the cycle starts and ends. The cycle starts when 2x minus pi over 4 equals negative pi over 2. The cycle ends when 2x minus pi over 4 equals pi over 2. So now we're going to solve both of these equations. For this equation, we need to add pi over 4 to both sides. Here is our side work. To add fractions, we need a common denominator. We'll get negative pi over 4. Therefore, 2x equals negative pi over 4. To solve for x, divide by 2 or multiply both sides by 1/2. We'll get x equals negative pi over 8. So here is one of the vertical asymptotes. For this equation, we need to again add pi over 4. Here is our side work. Pi over 2 plus pi over 4 will get us 3 pi over 4. Therefore, 2x equals 3 pi over 4. To solve for x, multiply both sides by 1/2. We'll get x equals 3 pi over 8. So here is another vertical asymptote. So we just found two vertical asymptotes for our function. Now if the function was y equals 10 cotangent of 2x minus pi over 4, the starting and ending equations would be these. Start when 2x minus pi over 4 equals 0, and end when 2x minus pi over 4 equals pi. So again, go back to your summary table on trig graphing and make sure you know all that information. Okay, for 29 through 43 odd, go to the next video.